So in Docker, we have about how many sessions? These are 5 sessions, and these are for about 17 days or 17 sessions for Docker, and material also uploaded. I think you are all practicing. And whatever, yeah. Hari, you are asking something?
No, I was telling yes, sir. Yes, we are practicing that.
Okay, great. Okay, without wasting much time, let's dive into Kubernetes. And this is the material that I'm going to give you. Material in the means it's my notes, which consist of about 100 pages. And we will be navigating to some official documentation as well, whenever it is required, but mostly it is there in the document itself. Okay, friends, let's begin our discussion on Kubernetes. 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 Kubernetes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 letters, 10 characters. So generally it is also called as K8S. Why? Because between K and S, about 8 letters will be there. So officially, it will also be called as K8S. And Kubernetes is a container orchestration platform. Kubernetes is a container orchestration tool. So the prerequisite side to learn Kubernetes is Docker. Okay, simply you need to have the understanding of the Docker image, Docker container, Docker host, container registries, and all those concepts that we have discussed in the Docker course is the prerequisite for this. And we know very clearly what is container. Container is running instance of a Docker image is called as container. You can think container as a lightweight virtual machine. Okay, so I'm writing container is nothing but running instance of a Docker image. Right? So image we know. Image is nothing but what? Application along with its dependencies packed together, wrapped in a file is called as image. Then what is orchestration? Orchestration means management. Kubernetes is a container orchestration tool. That means we should have the containers created by the Docker, and those containers will be orchestrated or managed by the Kubernetes. Many people will think that Kubernetes is an alternative to Docker, but it's not. Kubernetes requires Docker for the containers to be created in the cluster, and those containers will be orchestrated or managed by the Kubernetes. Then what is this orchestration and management? This orchestration is nothing but automating the deployment, scaling, networking of containers in a Kubernetes cluster is called as what? Orchestration. Not in Kubernetes cluster. Generally, automating the deployment of the containers. That means without any intervention from man, So by taking the GitHub or some declarative files as a source of truth, the Kubernetes will automate the deployment of the containers and their scaling up and scaling down based on the traffic and load balancing and networking of these containers is called as orchestration or simply management. So with this, we should understand that Kubernetes is a tool to orchestrate the containers which are created by Docker hosts. And one doubt is we have different kinds of containerization tools. For example, we have Docker, which is a most popular one. We have Rocket also, we have Podman. Okay. Those containers can also be orchestrated using Kubernetes, but we will stick to Docker only, right? So that's the thing. Kubernetes is a cluster of Docker host. Kubernetes platform is a cluster of Docker host. That means we will be having multiple Docker hosts in the cluster. And across this distributed environment, the containers will be deployed and they will be networked and they will be scaled up, scaled down based on the traffic, right? And they will be auto heal whenever a container is deleted. And in order to bring up the desired state, the auto healing process is also there. Okay. Now, let's go to our documentation and read some theory about that. Kubernetes is an open source container orchestration platform which is created by the Google in Go programming language. And this amazing technology has been open source since 2014. To learn Kubernetes, simply we should have some basic Linux knowledge and we should have thorough knowledge of the Docker, which we have already have during the Docker course. Okay, so that is here. Then I will take you to the architecture of Kubernetes, and before that, hi Tushar, where are you from?
Hey, hi, Laxman.
Okay, you were also part of the Docker course, or you are new to this?
No, I am new to this.
Okay, great. Okay, let's talk about Kubernetes architecture. I said that Kubernetes is a cluster of Docker hosts. What is Docker host? The machine in which Docker is installed is called as what? Docker host. So multiple Docker hosts will form Kubernetes cluster. We will learn each and everything. How to install Kubernetes in AWS. That means how to bring up the Kubernetes cluster in AWS. Then we will use KubeADM tool to install Kubernetes in our own virtual machines. We will see all those things. Kubernetes consists of cluster of Docker host machines. Cluster means they are a group working together to achieve a goal. Okay. This is it's a cluster of Docker host machines. And in this, one node or the one Docker host can simply, let's suppose that one node, these are called as generally nodes. One node will act as master. One node will act as master. So before understanding this, let's go to shipping industry. Kubernetes. Industry example. I hope that we will be getting that image which I have in my mind. Okay, so this is fine. Forgot to save that image. Yeah, this image. If you have some knowledge of the shipping industry, in shipping industry, we will be having both control ships and cargo ships. Control ships will consist of the information about the cargo ships. Cargo ships means the main ships which will transport the goods from one location of the world to the other location over the seas and oceans. And they should have some controlling mechanism. For example, these ships are meant for transporting the steel. For that, we may be having multiple ships to do the same task, and those that steel material will be transported by putting them into the containers. Okay, and in order to manage these ships, that means the information about how far this ship went, whether it has reached its destination or not, in how many hours it will reach its destination, whether all the containers are safe or not, whether the ships are safe or not, irrespective of the weather condition over the seas and the ocean. Okay, so all the information, all the signals about these particular cargo ships will be maintained by the controller ship. Okay, so like that, in Kubernetes also, we have these cargo ships are just, they are nothing but the workers, and this is nothing but the master, or in official terms, it is called as control plane. And these are called as nodes. This is node 1, this is node 2. So generally people will be calling this as master and slave. That's not right terminology in Kubernetes. Master slave, that wording is related to Jenkins. And here Kubernetes, we have control plane and the nodes, and we can call it as master also. Okay, but that's not a big deal. Now, this control plane is the thing which will assign the tasks, or which will assign the work to the nodes. By this, control plane will consist of some components which are not there in the nodes to perform its management activity. And every node will consist of some components, and those components are similar across the nodes, and they are different from the control plane components. Now, what are the components of the control plane? This control plane is what? This is nothing but a Linux machine. This node 1 is nothing but a Linux machine. This node 2 is also a Linux machine. We can have any number of nodes in the cluster. For example, in my current project, we have about 70 nodes. Okay, and they can be of different configuration. For example, it may have the 32 GB memory, some 16 core CPU, something like that. Okay, so that thing. So these are nodes are nothing but what? Linux machine. Now, what are the components in the control plane? The components in the control plane are Kube API server, scheduler, etc, scheduler, and controller manager. These are the components of control plane. In nodes, we have kubelet, we have container runtime, that is Docker in our case, and we have kubeproxy. And I said all the nodes will consist of same components. Okay, and these things forms a cluster. Okay, this forms a cluster. Now, in Docker, when we want to run a container, what we are doing? We are interacting with the Docker engine through Docker command line interface. Like that, to interact with the Kubernetes, we have CLI called kubectl. We have kubectl command line tool to interact with the Kubernetes cluster. I will come to this later. Then, what is control plane and what are its components? Control plane is nothing but the manager in the whole cluster where we will execute the commands or where the request from user will go. The request from users will go to the control plane. Okay, that's fine. But in control plane, we have 4 components. One is Kube API server. This Kube API server is the main component. Of course, every component is important. So this is the gateway, or this is the entry point for the request made by the client or the user. So that means if you want to run containers in the Kubernetes cluster, we have to send a request to the cluster. That request will be sent through kubectl command line interface or graphical user interface. But in 99.90 or 99.99% of the times, we will use the kubectl command line only. Okay, why? You will learn slowly. Then this kubectl has to be installed in our local machine. It will be installed in our local machine. Then we will request the Kubernetes to deploy a container with 5 instances. That means we want to have 5 containers which will run the same application. Why do we need to have 5 containers for the same application? That is for to get high availability. What does it mean? Let's suppose that we have only a single container. Let's suppose that we have a single Docker host machine. Let's forget about the Kubernetes. Let's suppose that we have only a single Docker host machine and we have deployed the container in that. Let's suppose that the Flipkart.com is the application which is running in this container. But what if this particular container is crashed or terminated or stopped? The entire Flipkart application will be down and it will lead to chaos, and it's a huge business loss for Flipkart organization. So what we are doing is we can run multiple containers in the same Docker host. That means we can run the 2 instances for the same Flipkart application. Okay, same Flipkart application is running in the 2 containers. With this, some improvement has been made. What is it? even if one container is down, still your application is up because the content is being served by this particular container, which is running the same application as that of the first container. So there is no issue. But what if the traffic is being increased? That single instance cannot withstand the traffic that is coming from the outside. In that case, it will also go down. If it goes down, then there is downtime. We don't want this to be happen. Or let's suppose that what if this entire Docker host machine is down? The entire Docker host machine is down. That means the two instances will be down. In that case, there is downtime. So there is no high availability here. Application is not available properly with minor failures, the application is down. In order to prevent this, we have beautiful tool called as Kubernetes, in which we will deploy the containers across the distributed environment. So what is the advantage of doing this? If we run the container in this machine, and let's suppose that 4 instances we are running. In control plane, in Kubernetes, this won't carry the load. We will come to that point later. In this case, if this container is down, still our application is highly available because the same application is running in this instance and in these two instances which are there in the node 2. If this entire node is down, still our application is available. If this node is also down, we will be having multiple nodes in Kubernetes. As I said, in my current project, we have 70 nodes. Of course, the number of nodes will depend on the number of applications that we want to execute. Okay, so our application is available. And in Kubernetes, we have the concept of auto scaling, where the containers will be automatically scaled up if the load is increased. For example, if there is a festival, Flipkart will give some offers. In that case, the number of requests that are coming to that Flipkart servers will be unusually high. In that case, the servers should have the capacity to expand. So that kind of expansion, that kind of scaling up is possible in Kubernetes, both at the container level and at the node level, which we will see going forward in the course. Now I want to request Kubernetes to create Nginx application with 4 instances. That means the request will be coming from the kubectl client, which is installed in the user's machine, and then where this request will go, the request will go to control plane, and more specifically in control plane it goes to kube API server. The request will go to kube API server. What's the request? The client asked to create Nginx application in 4 replicas. That means the same Nginx application will be running in the 4 containers and they will be networked. Now, the request came to the control plane and more specifically to Kube API server component of the master. Then first, this request will be validated whether the command given is correct or not, whether the Docker image that the client has specified is existing in the Docker hub or in the private registry or not. Those things will be validated by the Kube API server. Now let's go to the nodes. Let's see if I'm missing any point about that. See? So this Kube API server acts as the entrance to the Kubernetes control plane, and it is responsible for validating and processing the requests that are delivered using client libraries. Install this. Then the request came here. The request is something like, it will be in the form of, I will write it here. kubectl run name of the container. Let's suppose that nginx image gnx, and we will have other options here also. And let's suppose that this command is totally wrong. To have multiple containers here, we will come to that later. So let's suppose that this is a command that we want to specify. Usually we can't use this to create multiple replicas. We will use the deployment, which you will understand going forward. So the command will be something like this, and the command or the request came to Kube API server. Then there are two things. This application may be already running. That means the nginx containers, which are named as my nginx, may be already running in the Kubernetes cluster. Okay, generally in Kubernetes we call them as pods. Okay, but this is a basic understanding I'm telling you about. We will go deeper as we go forward. Okay, so we are requesting for creating nginx containers, and we want to create 4 containers. First, that means the my nginx application may be already running in the cluster. If it is already running in the cluster, the information about the are already created in the cluster will be stored in some database called as etcd. It's a database to store cluster information in key value pairs. So that means how many nodes are there in the cluster, how many deployments are there, how many pods are there, and what are the pod names, what are the networks. All the information about the whole Kubernetes cluster will be stored in some database called as etcd store. It stores the information about the cluster in key value pairs. That is fine. Now, why I'm telling? So we have requested here. The request came to Kube API server. Then the Kube API server will pass the information to etcd, saying that etcd, we got some request from the client saying that he wants to create nginx application with 4 replicas. Is it already running, or do we need to create it? So that way Kube API server will ask etcd. Then corresponding to that request or corresponding to that command, which is given by the API server that etc will give the information to the API server. It will tell that API server that the request that is being asked by the user is the deployment is not the information about whether that particular thing is already there in the cluster or not will be provided by the etcd database to the API server. Now API server got information saying that there is no such kind of deployment already existing in our cluster. Then API server now will pass the information to scheduler, saying that scheduler, please plan. The client is asking to create Nginx application in 4 replicas. Please plan accordingly. Then now the scheduler will plan where that particular 4 replicas have to be created. Scheduler, the name itself is self-explanatory. Scheduler schedules the containers or the pods in the nodes. That means we have asked for because where 4 has to be created in the node 1 itself, or 2 in the node 1 and 2 has to be created in the node 2, or 3 has to be created here, 1 has to be created here. In what way they have to be created, on which node the containers have to be created, that decision will be taken by the scheduler. Okay. It has some algorithms in it where it will just check for the resources in the nodes and other things, the node affinity, pod affinity, those things we will discuss during the course. And those type of conditions it will check. Based on that, it will schedule the pods on the nodes. So that is the job of schedule. That's fine. Now scheduler will pass this information to the API server that okay, so we need to create this node too. Okay, like that it will assign this. Now that particular request will, so the actual load is the actual load should be running on the nodes. Okay. Sweta is saying my voice is not clear. Is it true, friends?
Yes, sir. Yes, sir. Sometimes it is not coming properly because of the internet connection, I guess.
Okay, yes. Here also it said that I have unstable connection. Okay, let me switch to other network. Okay, it should be clear now. I will confirm that with some. Okay, it's good. It's good. Okay. So they are using the internet for TVs and other things. So I can't do anything as of now. That's fine. Okay. So now the actual load will be created on the nodes. Load in the sense the containers. Is my voice clear now, Hari?
Yes, Laxman, it's clear. Good.
Okay, thank you. So now the actual load has to be has to be created on the nodes. That means the containers have to be run on the nodes itself. So now scheduler has scheduled the pods or the containers on the nodes. Now, who is responsible to take care of this particular task in the nodes? So that component which is responsible to take care of the entire affairs of the node is kubelet. Kubelet acts as the agent of the control plane on the nodes. For example, in India, we have both central government and state governments, and center should have some control over the states to maintain the unity and integrity of the India. So for that, who is appointed in the states by the center? Who is the agent of the center in the states in India?
Is it governor?
Yes, governor. So governor is the agent of the central government in the state. So here kubelet will also serve the same purpose. Kubelet is the agent of the control plane on the nodes. So from time to time, kubelet will update the information about the node to the control plane. So control plane interacts with the nodes through kubelet. Now, the request came to kubelet saying that 2 containers with Nginx image should be created in this node. When the containers have to be created, it is Docker whom kubelet should consult. Now, kubelet will request the Docker to create 2 Nginx containers. Okay. Now, Docker, what it does is it will create 2 containers. Okay. Then later what will happen is these containers will be wrapped around a box. These containers will be put in a box. Then this is called as pod. Okay, so there is no much difference between the pod and the container. In simple Docker, single Docker host, we call them as containers, but in Kubernetes, some extra layer will be created over the containers. Then that is called as what? Pod. Pod means what? Generally it's a box. So containers are put inside boxes called as pod. It's some abstract layer over the containers. Okay, and going forward, you will understand the differences slowly. You will understand clearly the difference between the pod and containers. Now, these 2 containers are put inside the boxes and they are running in this node. So same thing. So the command was also given to kubelet. Here also the kubelet will ask the Docker to create 2 Nginx containers, and those 2 Nginx containers will be wrapped inside the boxes. That is fine. So now we know the role of kubelet. We know the Docker. Now let's come to kubeproxy. Hyphen should be there, or at least we should give the space there. Kubeproxy is responsible to assign the IP addresses, or in general, we can say that kubeproxy is responsible for networking of the containers. These 2 containers or these 2 pods are running the same application. So that means they have to be networked in such a way that the request will be load balanced across these things, which you will understand slowly when we understand the services concept. Now let's come to the theory of these things. etcd is a distributed key value store or a distributed key value database which acts as the single source of truth about your cluster. It holds configuration data and information about the state of your Kubernetes cluster. Now, kube scheduler, assigning tasks to a certain node considering its available resources and the requirements of the task is known as scheduling, and the scheduling will be done by the kube scheduler. Then kubelet, we have other components also. I will come to that later. Kubelet, this service acts as the gateway between the control plane and each of the nodes in a cluster. Every instruction from the control plane towards the nodes passes through this service. It also interacts with the etcd store to keep the state information updated. Kubeproxy, this small service runs on each node server and maintains network rules on them. Any network request that reaches a service inside your cluster passes through this service. Okay, you will understand this this para practically when we see the networking thing. Container runtime, this is nothing new to you. That is all about the Docker. So all about the Docker course is about this thing only. Now we have another component in control plane, that is controller manager. Now we wanted to create Nginx application in 4 replicas. That means the desired number of replicas we want to create is 4. What if one or the 2 containers are down or terminated? We wanted to have 4 replicas, but due to some reason, one or the other container is failed. In that case, the controller manager, and more specifically the replication controller, will ensure that always the desired number of replicas are up and running. So that means this control manager is responsible for healing of the failure things. Okay, so you will understand that as well during the practical classes, practical things. Then we have cloud controller manager as well. Before that, I wanted to tell you this Kubernetes platform is given as a managed service by AWS, and that Kubernetes platform is called as Elastic Kubernetes Service, EKS. AWS as a service called as EKS cluster, that is Elastic Kubernetes Service. In Azure, we have AKS, Azure Kubernetes Service. In GCP, we have GKS, GKE or GKS, I'm not sure, Google Kubernetes Engine. Okay, these are the managed services that are provided by the respective cloud providers. Now, this control plane is having that component called cloud controller or cloud controller manager. Okay, that will also come in this part itself. Let's write that separately. Cloud controller manager. If we install Kubernetes with our kubeadm tool, then this cloud control manager won't be there because we are installing the Kubernetes in our own virtual machines. But if we use any of these cloud-based Kubernetes platforms, then in control plane we have a tool called a component called cloud control manager, which wires up this Kubernetes cluster with the cloud to get the virtual machines, to get the load balancers and others. So this is nothing but an API between Kubernetes and the cloud providers. Now, these things we understood. Now let's slowly go inside the deployments things. In Kubernetes, we don't directly deploy the containers. Instead, containers will be deployed inside the pod. So that's why pods are the smallest deployable units of computing that you can create and manage in Kubernetes. That means when we are scaling up means we are scaling up the pods, not the containers. And there is no major difference. When we are scaling up the pods means clearly we are scaling up the containers. When we are scaling down the pods means we are scaling down the containers only. But in Kubernetes, we have to use the term pod because pod is the smallest deployment unit in the Kubernetes. Smallest deployable computing unit. Okay, so that is pods. And we generally don't deploy the naked pods. Instead, we will deploy the pods by using some higher level objects called deployments, replica sets, and replication controllers, other things which you will learn going forward. So a pod usually encapsulates one or more containers that are closely related, sharing a life cycle and consumable resources. So that means a pod can have multiple containers as well. So it's not that only a single container should be there in the pod. No. We have the multi-containers pod as well. We will understand that. Okay. So if somebody asks, can we have multiple pods in the multiple containers in the same pod? Yes, we can have. But in about 99% of the times, we will be using only single containers pods only. But we will also understand how to create multi-container pods. And when a pod is having multiple containers, there is some purpose which you will understand in that section. So now finally, we have a Kubernetes cluster, and in that we have node. Inside that we have pod. Inside pod we have container. Inside the container, the application will be running. That is the flow. One thing is, I told you in the beginning that Kubernetes is a cluster of Docker host machine. Yes, these are all Docker host machines only where the Docker is installed. But coming to the control plane, Docker is not there. So when I'm using this control plane, I'm specifically talking about the Kubernetes platforms which are provided by any of the major clouds. Okay. So when we are using Kubernetes means definitely we will be using one or the other platform from the cloud. So these components will be there. So in this particular managed services, control plane doesn't contain Docker host, Docker in that. So that means in control plane node, containers or the pods won't be running. The pods will be running on the nodes only, not on the control plane. The control plane will take care of management activities. Okay, so that's the thing. And as I said, there are two ways to communicate with our Kubernetes cluster to deploy the containers or the pods. One is through kubectl command line, another one is through GUI. But in 99.99% of the time, we use kubectl because we can put these commands in the shell or in Python or in the Jenkins pipelines or any pipelines you are using. So they will be writing the kubectl commands in the pipeline. So in the declarative way. So that's why we will be using this thing only. Then in Kubernetes, there are two ways to deploy the containers. One is through imperative way and there is through declarative way. Mostly we will use declarative way. Declarative way means we will define the desired things in the Kubernetes manifest files. Those manifest files are nothing but YAML files. In YAML files, we will write the desired state of our application, how many containers have to be created, what's the image that we want to use, so what are the networking solutions, and all those things we will writing in the manifest files. Those are called as manifest files. Those are nothing but the YAML files. Now, what's next? Now, how to install this kubectl? This is the first step we need to do. So before installing this Kubernetes, before creating this Kubernetes cluster in the AWS cloud, so we have to create this kubectl client. This is something like some package which we can directly download from here. Okay. Now, with this, you should understand that whatever the Docker images that we have created using the Docker files, those Docker images we will specify here in this. The request, we have to specify the Docker image name from which we want to run the containers. That will be specified in this particular thing. For that, to create the Docker image, we have the Docker file concept, which we have learned in the Docker course. So this kubectl is installed, downloaded. What we need to do is we have to set the environment variables for that. Otherwise, what you can do is simply you can copy and paste that into system32 directory, system32 folder. So now let me stop my screen share for some time. Okay, that's fine. Let me share it. Somebody asking some question. Please upload these notes on Google Drive. Will there be class tomorrow too? Yes, Imran. They will be creating this another drive for the Kubernetes, and they will be giving me the access. I will upload these notes there. Okay. That's the thing. Then wait a minute.
Sir, will there be class tomorrow?
Tomorrow, yeah, class is there. So Republic Day, so morning we will celebrate, right? So evening we will be having class.
Okay.
Okay, so you just have to copy this kubectl executable file. Okay, something. Yes. So I'm sharing my screen now. So you just
So Laxman, like all these demos, are we going to do on our system, or are we going to use some AWS machine or something like?
In AWS, we are going to create this Kubernetes cluster, and this particular kubectl we will install in our local machines only.
Okay, so from day one itself, you are going to set up the EKS cluster?
Yes, tomorrow class is to create the EKS cluster in the AWS.
Okay.
Without cluster, how can I tell these practical things?
No, I was, just checking whether we are going to set up the kubeadm or we are going to set up the
Not
EKS.
kubeadm, we are going to create the EKS cluster in the AWS. We will also learn how to use the kubeadm also.
Okay.
Okay. So this kubectl got downloaded. Let's go to Windows, and in system32, you just have to paste it here. After that, you place open our VS Code. So some things that are already there in the system. Let me go to this demo AS directory. So something here. So now if I come and open a terminal here, we have downloaded the kubectl and we have copied that to system32 directory folder. then type kubectl --- version. So command the previous. Okay, so with this we will get we got that that kubectl is installed. Kubectl --- help use, we will get the things kubectl just to use this also. So this kubectl got installed in our local machine. Tomorrow what we do is we will create this Kubernetes cluster in AWS and we will establish a connection between kubectl and the Kubernetes cluster so that we will be deploying the things from our local machine into the Kubernetes cluster. That's it for today, friends. If you have any questions, you can ask me. And those who have joined exclusively for this Kubernetes course, and they can make payment and they will get the notes and the videos in the Google Drive. And other thing is that these demo classes will be continued for 2 to 3 days. Today it's Wednesday. Up to Saturday, these demo classes will be there, so that later you people can decide. I'm telling the people who join for this Kubernetes course. Okay, so that's it for today, friends. If you have any questions, you can ask me. Otherwise, we can wind up this session.
Yeah, hi Laxman.
Yeah, Subbarao.
Yeah, Laxman, how many days it will take to complete the entire course? I'm new to this.
So Docker, it took about 17 classes. This will take about 20 to 25 classes.
Okay. I think I have a less knowledge than Docker. Can I continue this session? Because I know how to write a Docker.
Yes, you can continue. So if you know about container, so that's fine.
Okay.
At least you know about the image. So that image we will be using the Kubernetes manifest file to deploy the things in the same.
Okay.
Okay. So for these new people, I just want to briefly tell you about these things. So classes will be from 8 p.m. to 9 p.m. From Monday to Saturday. Monday to Saturday. Then you will be getting live sessions.
Your screen is not shared in case you are writing.
Oh, you must be telling. Okay, so live sessions, recordings, and notes will be provided to you. And the course for this fee for this particular Kubernetes is 2,005. So that's it, friends. Let's wind up this session. Let's meet tomorrow at the same time. Thank you. Any questions? Could you please little bit louder, Vivek?
Yeah, Laxman, can you hear me now?
Yes, yes, I can hear you.
Okay, so even I joined today only for the Kubernetes course. Yeah, tomorrow I understand that we have to create a cluster on AWS, right? So do we need a free account or how do we go about that?
Yeah, we need to have AWS account. So that means tomorrow I will teach how to create and all those things. If you want to practice, definitely you should practice, right? For that, you should have your own AWS account.
Okay.
So to create AWS account, you should have a debit card or credit card with international transactions enabled. It will take about 24 hours for the account to be created.
Okay. All right. So is that how much will it charge for us to create an EKS cluster of
EKS
2 nodes?
cluster, it depends on how many
2 nodes, let's say like
2 nodes. Okay, so overall, for example, to teach my class for these many days, for 20 to 25 days, it will be about costing will be about below 1,000 rupees only. Okay, so each day I will teach about 1 hour, and for these 2 months, for this Docker and Kubernetes, I will take about 50 to 60 days, and in that only about 50 classes overall, about something like 35 to 40 to 45 classes, below less than 1,000 only. Okay.
Okay.
Provide that we have to delete the resources once our work is done.
Correct. Correct. Yeah. Yeah.
I will tell you how to manage that.
Sure.
Okay, friends, all of you, please be ready with AWS account, and in that we will install our. Or if you are comfortable with Azure, the only thing where we are creating the cluster differs. Every single command is same, whether it is AKS, EKS, or anything. Once we connect to the clusters from our local machine, we will interact with the cluster in the same way for all the things. Okay. Okay, friends. Thank you. Bye.